Okay, question 8. So a new road bridge has been built. Excellent question. A worker paints that many lines on the centre of the roads. I think I'm going to get a machine to do that these days, but okay, imagine a wee guy doing that. Brilliant. Each line is 4 metres long. So again, let's think of what we've got. 367 lines. Okay. 4 metres long. So I've used that. There's a gap of 2 metres between each line. Okay, so I've got that many lines. Okay. So between here, I've got a 2 metre gap. So if that was line 1, 2, 3, all the way up to 367, you're going to have 366 gaps, aren't you? You've got one less gap. So you've got a gap after every line into the last one. Okay, so I'm just going to say I've got 366 gaps, which are equal to 2 meters. Okay, so I've used that. The first line starts at the beginning of the bridge. Okay, so the bridge is right here, right at the beginning. And the last line finishes at the end of the bridge. So there's the last line at the end of the bridge. Okay, calculate the length of the bridge. All right, so seems quite straightforward then. All we're going to do is say I've got 367 multiplied by 4, and to that I'm going to add on the 366 gaps multiplied by 2, and that should come out as 2,200 metres, or 2.2 kilometres, which they seem to call clicks in the movie, don't they? In movies, when they always talk about, when you watch army movies, 3 clicks from the LZ, all that stuff. But yeah, kilometers. I'm sure that's what it is. So a wee bit of visualization. For me, the hard bit is really the gap, isn't it? It's just trying to go, oh, how many gaps are there? And you've got one gap per line, but then there's no gap after that last line, is there? So you've got one less gap. Okay, that's and yeah, I can manage to visualize that by drawing it. I would suggest you do the same as well. So yeah, just 2 marks. You would get a mark for knowing the number of gaps, and then a mark for your final answer. So if you got the gaps wrong, you would have still got a mark here. But yeah, a wee bit trickier with that bit. And this one, there's a lovely bridge. Looks like 2 cables. Yeah, we got a wee cable stay bridge. Yep, so calculate the total length of the cable. So we're looking for the length of this cable here. It's not a very well designed bridge. This usually bridges are symmetrical for a good reason. Let's keep things nice and balanced. Not always, but you know, it's architectural choice. Anyway, that's a different video. So yeah, the total length. You see a triangle. You should be thinking to yourself, we're going to have to use Pythagoras to work out that. Okay. So for the first one, I know the cable here is 300. I'm just trying to work out the length of this cable. But to do that, I'm going to need to work out this height first of all. Yeah. So if I was to do Pythagoras once, that can help me get that height. So that's 300, and that's 295. So if I do Pythagoras, I'll call that h. So h squared is 300 squared, take away 295. It's a Pythagoras takeaway because I've got the longest side. The longest side is always opposite as right angle, so I'm doing a takeaway. So h is going to come out as, we'll call that 54.5. Very good. And now I'm able to work out the length of the other cable because I know this is 54.5. I know this is 600. And there's my right angle. So the cable x, this will be Pythagoras add. So x squared is 600 squared plus 54.5 squared. So my x will come out as 602.4. And my final answer for the cable will be to add the 300 to that. So it's going to be 902.4 because I've got a 300 and I've got my x. Don't add in this one, obviously. So you see a triangle, you should think Pythagoras and do a little diagram. You can't really go wrong if you forget what's add or subtract. Always know opposite the right angle is the longest. So if you know that's the longest side, do the add. And then look and go, wait a minute, that number doesn't make any sense. Then do the takeaway. So as long as you know that rule, that this is the longest side, you can do whatever you like to here because you just have to make sense of your answer. Here that makes sense. If I did an add, this number would have been, bigger than 300, so I would have normally made a mistake. Okay, so just know that this is always the longest side. Opposite the right angle is the longest side. Okay, but nice wee question, that nice wee question. Let's try question 9. I can't construct your pie chart, but I'll help you with the sums you would do to do it. So we're going to look at his hours on here. So the first thing I'll do is do my total hours. So if I add all them up, I should find that I get 540. Okay, so the total is 540 hours. Yeah, and that's going to be equal to my 360 degrees. Yeah, so all the way around here, 540, that's 360 degrees. So 210, so let's say I've got 210 hours out of my 540. I'll call that research. And for meetings, that's 96 out of that 540. And for writing, maybe a bit more time on the writing. It's just half. Well, I suppose research. Yeah, okay, I'll give them that. I'll give them that. Just thought maybe it would have been closer to more than about half. 540. So that's the ratio of the time over the total time. Yeah. So if I say 210 divided by 540, that gives me 0.388888, and 96 divided by 540 gives me 0.1777, and 234 divided by 540 gives me 0.4333. So that's like your percentage almost. That's like 39%, 17%, 43%. But what good is that for me? How do I get that into degrees? Yeah, well, all you have to do is say, well, if I take this number and multiply it by 360, that will tell me the associated number of degrees for each of these. Yeah, that's it. This is like your ratio of time. So if I take the ratio, multiply it by the total, that's going to give me how much? So the first one should come out as 140 degrees. The second one comes out 64 degrees. And the last one, 156 degrees. And you would use your protractor to draw that on. Okay, so just you can do that in one step. I just thought I'd show you this number to kind of show you that it's a ratio, it's a percentage, it's decimal. 38%, 0.38. And if you take that and multiply it by this, you get that. So I'll do it in one step. I'll do this times the 360, but I just wanted to show you the rough number. And obviously that, would all add up to your 100%. If it was a nicer numbers, that might come out as like 0.25, it's a quarter, 90 degrees, But I just thought I'd show you that. And I think we're going to run out of time, so I'll do this on the next video. Okay.